Hey there, in this video we are going to look at how we can choose a graph from an equation in a multiple choice style question. So the simplest way, when we are given an equation and we are given answer choices that have graphs and we're asked to pick which graph matches the given equation, I would suggest that you plug in two values. I would suggest you plug in x equals 0 and y equals 0 into the equation, and then if you plug those in, you can see those 2 points and you can identify which graph has those 2 points on it. Now, I would suggest those because 0 is typically the easiest number to plug in and simplify quickly. Additionally, if you can find 2 points on a line, remember that with a line, if we know 2 points, there is only one line that will go through those 2 points. So no matter which 2 points we end up with, there's only one way to connect those points as a line. So if we can get those 2 points, that will automatically tell us which of the 4 or however many answer choices there are, which of the answer choices shows the correct graph to match the equation. So let's take a look at this first example. We are given an equation. So it says choose the correct graph for the equation 3x plus 9y minus 4 equals 14. So what I would suggest you do is go ahead and plug in x equals 0 and plug in y equals 0. So let's start with x equals 0. So if we plug in x equals 0, then we're going to do 3 times 0 plus 9y minus 4 equals 14 and solve that. So 3 times 0 is 0, and 0 plus anything is not going to change what that other part is. So I'm just going to simply ignore this part here since that's 3 times 0. So we really have 9y minus 4 equals 14. So next we'll want to add 4 to both sides so that we can isolate the 9y. And that gives us 9y equals 18. At that point, we want to go ahead and divide 9 on both sides, and we end up with y equals 2. So our coordinate, our ordered pair here is going to be 0 for x and 2 for y. So you can either go ahead and plug in the y equals 0, or you can pause at this point and go ahead and figure out which graphs have 0, 2. So if you think about from the origin, 0, 2 is going to be going up 2, and this would be that point 0, 2. So if you look at all your graphs, A has that point, B has that point, C does not have 0, 2 up here. It is not on that graph, and then D does. So we can actually go ahead and eliminate C right now. And so we have between A, B, and D as our remaining options. So now we're going to do the exact same thing, but we're going to put 0 in for y. So we will have 3x plus 9 times 0 minus 4 equals 14. So again, anything times 0 is 0. So 9 times 0 is 0. If we have 3x plus 0, that's not going to be changing the 3x. So we're just going to ignore this 0 right here. So we'll have 3x minus 4 equals 14. Add 4 to both sides to isolate 3x. And we get 3x equals 18. At that point, we divide both sides by 3 to isolate x, and we get x equals 6. So our ordered pair for this one is going to be 6 for the x coordinate and 0 for the y coordinate. So starting at choice A, we see 0, 0 is our origin. So we go 6 to the right, 0 up or down. So that's going to be this point right there. So I notice that this is the correct graph, but just to triple check, you can quickly glance and see that none of the other ones have that same point. Otherwise, it would be the exact same line. So there is no 6, 0 on graph B, and there is no 6, 0 on graph D. So that's how we know that A is the correct choice on that one. Now, looking at example 2, I wanted to show you that if you do understand how to graph in slope-intercept form, for example, that can actually save you some time. So on this one, personally, instead of plugging in 0 for x and for y, if I notice that this is in slope-intercept form, y equals mx plus b, I would realize that the slope is going to be 3, and the b is going to be -2. That's your y-intercept. So we know that our y-intercept is going to be at 0, -2. So I can look at the graphs And I can go ahead and see which ones do not have that point right off the bat. So I see that A does have the point 0, -2. B does not. So I can cross that out because there's not that point right here on the y-axis. And then we do have the point on option C, but we do not have it on D. So right there, I eliminated B and D just by realizing that with slope-intercept form, that constant at the end there is our y-intercept. Now, additionally, the slope is positive. So if you know about slope, like we've talked about, being a positive slope, the line is going up from left to right, which means out of option A and option C, C has to be our answer because it has a positive slope and it has the correct y-intercept. So that right there saved us a lot of time and not having to plug in and do calculations and risk making a mistake on the calculations if you understand that slope and that y-intercept when it is in slope-intercept form. Now, on the last one that we just did, it wasn't in slope-intercept form, so that's why I didn't mention it on that problem, because on that type of problem, plugging in is probably just about the same amount of time as getting that into slope-intercept form and then using this method that we talked about. Now, I do want to point out, if you are not as comfortable with knowing the effects of M and B, you can still use that same concept of plugging in x = 0 and plugging in y = 0. And if you do that, you'll end up with 0, -2 as one of your intercepts. And then your other one, you'll end up with 2/3, 0. And so you could go through that whole process again where you would plug in 0 for x here, and then plug in 0 for y here, solve each of those, get these intercepts, and then come to the graph and see, okay, the only one that has that 2/3 0 in that 0, -2 is going to be option C. So those are two methods that we can use to figure this one out since it is already in slope-intercept form. So either way works. So in a quick summary, what will always work no matter the format of the equation given to us when we are trying to match an equation to a graph, we can always plug in, for example, x = 0 and y = 0 and get two ordered pairs, 0, some y value, and then x, 0. Now, once you get those, remember you can check your graphs, rule them out, and see which one actually has both of those points. However, if it's in slope-intercept form and you feel comfortable, remember that you can use the B, which is your y-intercept, and the M, which is your slope, to figure out which graph is correct.